Hi. Thanks everyone for having me. My name is Bobbie Chen. I'm a product manager for Anjuna, and today I'm going to talk about lessons learned from our customers' deployments of confidential computing. Anjuna is a confidential computing platform. This company was founded in 2018, and we've been helping customers like the Israeli Ministry of Defense get the benefits of confidential computing ever since. I'm going to start here with a demo of a real customer deployment of enabling a major bank to safely scale. So here, there's a major bank, and they want to have a smooth digital experience for millions of customers, but without sacrificing the compliance controls in their on-prem solution. And so before, we can see that the existing on-premise solution has some components moving to the cloud, but others not. And so as we have users, and more of them are using online banking to get their transactions, the customer digital experience layer here is able to grow, but the operational data store layer, which is still in the data center, doesn't scale elastically. And so what that means is that our transaction costs are increasing, the average latency is increasing, and for the users, this is giving them a poor experience that they're waiting longer and longer to get their results. And this is hurting the bank's reputation with those users. So the bank wants to move this operational data store layer to the cloud so that they can elastically scale it. But if they just move it directly to the cloud here, they may be exposing PII and encryption keys to threats that they cannot control because they don't have full control over that cloud environment. So they used Anjuna to protect their customers' PII and their keys. And so the way that this works from the architectural level is that when data leaves the data center, it fetches an encryption key from AWS KMS and uses that to encrypt the data. It then pushes it into a MongoDB, which is hosted in the cloud. And then the operational data store layer actually runs in AWS Nitro enclaves using Anjuna to get the benefits of confidential computing without having to totally rewrite their application. We're using the attestation capabilities of AWS KMS to make sure that only these ODS nodes with the right measurements can access those keys that are needed for the data. And so this means that when a customer transaction arrives, the ODS is able to use field level client side encryption with the MongoDB. They're the only ones who can access that data. And so it's only ever in plain text inside the secure context of the enclave. And so now this means that we can enable the cloud migration in production. And we can see that the system performs a lot better now, that as our users scale up, we are able to elastically scale out not only this CDX component, but also the ODS component. And this keeps the user latency down fully. And so this was a good starter project. We're looking to continue to raise the security bar for all their future applications and enable their cloud migration. I really like this customer demo, this customer use case. It shows that confidential computing is not just about improving data security in a vacuum. It's actually enabling new use cases and experiences that weren't possible before. So moving into the rest of the presentation, today I'll be talking about three big topics that come up in every production customer deployment. It's attestation, observability, and performance. So we'll start with attestation. We talked about this already in the keynote. There's a whole track at this conference about attestation. So we here know that it's important, but some of our customers don't initially see the need, and they focus on encrypting data in use only. And to justify it to them, I usually pull out something like this diagram. As a client or as someone talking to a service, I only want to give my data if I trust that code and it's running in an enclave. If it's not, who knows if there's actually an evil service that I'm talking to who's going to do something bad with the data, or it's a service with less protections than I'm willing to trust it with. And without attestation, it's not possible to know whether this service is one that I trust or not, and whether it's running in an enclave or not. Once we've established that we do want to do attestation, there's a bunch of questions, and I'll go through them. It's sort of the what, who, how, where, and when of these things. And I'll start with the what. And so the first question is really, what are we attesting exactly? And how granular of an identity do you need? There's a lot of different layers in software. But what we found is that our customers generally want attestation for their workload level logic and their business logic. And so I'm going to call it one specific use case, dynamic code loader, something like open functions as a service or Knative are often not a granular enough level of attestation. And so for these kinds of services which load code, if you do attestation against the open fast server, you're basically going to say, I trust that the code here is actually going to take some other code and run it. But that attestation doesn't tell you anything about the actual function that's going to run. And since that's what's going to see your data, if you don't have an attestation for it, oftentimes your customer is not going to be okay with that. And there's a metaphor here around, I think with attestation, we're always trying to find metaphor since it's such a technical concept. But I think there's a metaphor between if I want to identify people, then seeing the license plate, something which contains people in it, of a car, that's not really going to help me determine identities at the granularity that I want. So we want to ask, what is the piece of code that we want to do attestation for? Next question is who's checking? And basically, this is the insider outsider question because there's a different level of trust for outsiders. I think there's actually two parts here. And I'm hoping to hear about more, honestly, in the other talks at this conference on attestation, because there's two parts here. You need to be able to map your measurements back to some code, and you also need to be able to trust that code. And both of these are hard problems. I mean, something that I like is the International Obfuscated C Code Contest. It's a really good explanation, demonstration, I should say, that it's possible to write reasonable looking code that actually has unexpected results. So there's also a level of security expertise needed to understand whether we trust the code or not. And for some organizations that we've seen without that level of security expertise, they might be able to learn from an audit from an outside company like a Leidos or an NCC group. The next question is how? How does the verifier check? And specifically here, at Arjuna, a lot of our customers are willing to trust the managed cloud service and others are not. And so if you're using Azure Attestation or AWS KMS or another managed service, you have to consider that these have integrations and they're configured oftentimes at the cloud administration level. So let's say you're using Microsoft Azure Attestation with Azure Key Vault. You need to consider in your threat model that maybe your cloud admin is going to get compromised and your cloud admin has the ability to turn off the attestation requirement at the Key Vault level. So that's something that you need to consider and plan for. Now, if you're not using a managed service, then you'll also need to provide code for your verifier or somehow otherwise establish trust that this piece of code, which is actually doing the verification of an attestation quote, is going to tell you if it fails verification correctly. The when and where, once you've answered the other questions, these should be a little more clear. But on Juno, we've actually seen a repeatable pattern play out for our customers, which I'm going to call attested boot time secrets. And so an application needs secrets. When it boots, it will generate an attestation and use it to fetch those secrets. And this could be something like a TLS certificate, an API key, database credentials, whatever it is. And so this is a common and useful pattern. So we've actually built it into Anjuna out of the box with integrations for AWS KMS or the self-hosted Anjuna Policy Manager. It's these kinds of usability pieces that help our customers get the benefits of attestation without having to write a bunch of heavy lifting code on their own. Now let's move on to observability. The question we always get from customers is, how do you get logs and metrics out of the enclave? There's a bunch of different ways you can do this. And we basically ask them, well, how do you do that today with your existing applications? There's kind of two buckets of answers that we get. So some of our customers are using remote observability tools. These are things like Prometheus or Azure Monitor, Splunk, Datadog, Logstash, and there's a whole host of tooling like that. And for those customers, we say, great, nothing is stopping you from using these tools with enclaves. Generally, you're just pushing some data to a remote server. But some of our other customers will use SSH. They will SSH to a production server and debug it live from a shell. And this one is not a good fit for confidential computing. I mean, it's technically possible. You can probably run an SSH server in an enclave alongside your application, but it really defeats the purpose of having an isolated and secure environment because anyone who logs in is able to interfere with that environment. And so we direct those customers to also adopt some remote observability tool. And so we find that the customers who are using SSH to debug are generally smaller companies. A lot of the larger and more mature companies have to follow certain compliance controls, and their compliance controls will require that they limit access to change their production servers. And so now you're using a remote observability tool. Once you're doing that, you also need to make sure you're not exposing sensitive data. And this can happen at two different levels. Because you are causing data to exit the enclave, either at the application side, you might be, say, logging sensitive data. Like you don't want to be logging a social security number, for example, and having that be sent out to some remote server. You want that sensitive data to just stay inside the enclave and never leave. On the storage side as well, once you've shipped these logs off to another server, you also need to manage access to that storage server. So if I'm sending my logs and metrics into a public S3 bucket that anyone on the internet has access to, that's probably not what I want. And I should be restricting that to either my company level at the bare minimum, or even better, to just the team that needs access to those logs and metrics to do their job. So in summary, well, you want to use a remote observability tool, and you want to configure it to limit sensitive data access. And finally, let's talk about performance. I'm going to tell you about a specific experience that we had. For this customer, and this is a Fortune 500 company, we were running one of their existing applications in an enclave. And so we had completed implementation. We were moving to performance testing when we got these initial results back. And these results showed unexpected latency compared to similar applications for customers running in enclaves that we've seen before. So we see this gap and we know something is up. And we asked them for more information about their application and about their environment. And we discovered that one issue with the testing is that their environment was different. So their test client and their baseline application, which is not running in an enclave, those two were running in the same VPC, essentially, and the enclave application was running in a different one. And since crossing VPC boundaries adds latency, this meant that we're not really making a meaningful isolated comparison. That when you make the network environment equal, we asked them what's this actually going to look like in production, and the clients are not going to be in the same VPC. So we asked them to redeploy the test client in a different VPC, and we see that the gap is smaller, and this is getting closer to what we were expecting. At the same time, we identified a potential performance improvement in Anjuna, and we shipped them a new version of the code. And we asked them to test this, and we saw an unexpected upwards trend in latency instead of the expected improvement. So this was weird. We looked a little more closely at the test results, and we actually found that the results appeared to be identical between different runs. And what I mean is that here on these pink lines between the graphs, these numbers were identical down to the decimal point. And so this made us think maybe we're not rerunning the tests, we're just copying over the results of previous tests. And this can be a problem at times because the cloud is a dynamic environment. And for example, VMs can get live migrated into different physical servers, network routes can change, and that can change your performance results. So we asked the team to rerun their tests for both the baseline and the new code, and we found the expected improvement from the code change that we shipped. And so this is a much smaller gap than originally measured. I want to point out here that if you look at this graph at face value from left to right, it might look like things are getting slower, which is a bad thing. This is not really what's happening. And what's happening is that the earlier tests are invalid for various reasons. There's a lot of factors that go into performance. And basically, the earlier tests are not measuring what we actually care about, which is how much the enclave affects the performance, and not how much does crossing a VPC boundary increase the latency. So we have a couple takeaways here, is that we always want to be comparing apples to apples. That's the same environment, but also the same resources. We want to be shipping and measuring our changes in that same environment with the same test methodology. And what this implies basically is that we want to do a lot of automation in our testing, because this means that anytime you tweak something in your configuration, you can rerun your tests, get new results at the same time, and be able to do that over and over again, knowing that your test isn't changing as well. And so after a few rounds of testing, we found we had minimal performance overhead. And our customer looked at the final results and they said, maybe we can get more performance from other places. And so they were actually able to get help from the cloud service provider they were using to further improve their performance by tweaking network architecture at the cloud level. And so one piece there is that performance is a property of the whole system. And I think here we're often focused on the pieces that are confidential computing, since that's what we're focused on, that's our expertise. But at the end of the day, every other layer of the stack also contributes to the overall performance of your system. And so as a recap of these things, we talked about attestation, where you want to ask the questions what, who, how. These are really going to affect your implementation. And you can always come back and change it later, but if you ask these questions upfront, you'll come up with a better design. One of those designs might be the attested boot time secrets pattern. We talked about observability, to use remote observability tools and control access to sensitive data that might be logged. And to do performance testing, compare apples to apples, ship changes and remeasure them, and measure the performance of the whole system. You might think these are pretty standard suggestions. And honestly, that's the biggest takeaway for me. The bottom line is that software running in an enclave is still software. And that means that we can build up from what we already know today. We can continue to use the same tooling and processes and learnings to make sure that we're delivering good production experiences for our customers. That's all I've got. This is Anjuna. Thank you so much for the time.